Okay, so if you're doing exercise 8E as part of your remote learning, so if you're currently in the first year, you do not need to do this question, okay, because you haven't integrated trigonometry yet. Okay, so just say that again. If you're doing this exercise as part of your remote learning, you should be skipping this question out. Okay, I'm going to do the solution for anyone else that's doing this, but it's got second year integrating in. Okay, but assuming you are tackling this question, we are looking at the second year textbook and second year Stats and Mechanics textbook, and we're doing exercise 8E. So we are given the velocity, and we're asked, no, sorry, ignore me, we're given acceleration, and we're asked for velocity. Okay, so velocity is the integral of acceleration. So the I component is fine. It's just the J component you won't be able to do if you've only done first year core maths. Okay, right. I'm going to integrate that with respect to t. So 2t minus 4 is going to integrate to t squared minus 4t. And then sine t, so this is what you won't have done if you haven't done your second year core yet. But sine is going to integrate to, let's get this right around, sine is going to integrate to minus cos, so that is going to integrate to minus 6 cos t j, and then because I've integrated, there's going to be a constant. Okay, right, and okay, I just realised there isn't actually a question here yet, so I think I need to go on to the next bit of it. I'm just sort of assuming it's going to ask me for velocity. Let's hope that it does. Okay, so let's see what the actual question says. Okay, right. So yes, I'm asked for v in terms of pi and t, and it tells me. So see, there's no reference to radians, but again, when you've done your second year integrating, you'll know that calculus only works if it's in radians. Okay, so p is at rest, so v is 0 when t is pi over 2. So v is 0, so if I do pi over 2 all squared, that's pi squared over 4, so I'm just substituting t is pi over 2 into that, and then 4 times pi over 2 is going to be 2 pi. Then cos of pi over 2, it's just 0, so that's just going to be 0, and then plus d. So d must equal, so if I minus that, d must equal minus pi squared over 4 plus 2 pi I. Okay, so that would mean that v is, so then I'll write it out unsimplified and then tidy it up. So I'm going back to, let me do that. I'm going back to this line here. So v is t squared minus 4ti minus 6 cos tj, and then minus, well, what's the best way to do this? I think I'll do it as plus minus pi squared over 4 plus 2 pi, just about squeeze that in on the end. I'm going to move it up so you can actually read it. Okay, and then I should just get all my I vectors together. So v is t squared minus 4t minus pi squared over 4 plus 2 pi I minus 6 cos t j. Okay, so they are my constant, but I can't sort of, unless I go to a decimal, I can't really add those together. I could write them as a single fraction over 4, but I don't think I need to do that. But let me just check. T squared minus 4. Yeah, that's good. Okay, and then the exact speed, right? So exact speed tells me I need to keep working in terms of pi. Okay, so I don't want to start getting these as decimals, and you will assume that anyway. So when you're doing more of your second year calculus, you will leave everything in terms of pi. Okay, so, well, first of all, let's get the velocity. So yeah, so basically this question is now quite tricky because of all the simplifying. So 3 pi over 2 all squared is going to be 9 pi squared over 4. Yeah, that's just squaring all of that. Minus 4 times t, so that's going to be 6 pi. And then I've got the minus pi squared over 4 plus the 2 pi. And then I'm doing cos of 3 pi over 2 is 0 again, so the j component is just 0, so I don't need to bother writing that. Okay, right, so that's quite good news, because normally if I was finding speed, I'd have to do, so I've forgotten to say that's the I vector. So normally if I was doing speed, I'd then have to do Pythagoras. But if it only has an I component, so basically it's traveling due east, it's traveling just to the right, then its velocity, the magnitude of its velocity will just be the coefficient of the I component. Okay, so basically it's just moving that way. It's moving in a straight line in that direction. So I don't need to worry about Pythagoras, which is quite nice because I didn't fancy having to square all that. But what I do need to do is simplify that down. So I've got the two terms that are in terms of pi squared. So 9 pi squared over 4 minus pi squared over 4 is going to be 8 pi squared over 4. The problem you're going to have is if you just try and type that into your calculator, it's definitely going to come out as a decimal. And obviously that will cancel down to 2 pi squared. And then I've got the minus 6 pi plus 2 pi, so minus 4 pi. Okay, so that's its velocity. So the speed is just the magnitude of that, so that the 8 pi squared over 4 simplifies to 2 pi squared, and the 4 pi is just 4 pi, and that's in meters per second. Okay, so let's just check that. 2 pi squared minus 4 pi, we are